Tim, you're a senior JavaScript developer, yeah?
Yeah.
And you're based in Sydney.
Yes.
And so what are you talking about today?
It's going to be revealed in my talk.
Okay, got it. Everyone, please welcome Tim.
Thank you. Yeah. Hello, everyone. I'm Tim. I work in Sydney on JSD Server, and today I'm going to talk about fast, performant, high-quality front-end app development for Jira Server. And because that's an awkward long title, we can make it a little shorter. Because the things I'm going to talk about today are valid for literally every server product out there. And because that's a bit too short, we can make it longer again. By server, I mean server and data center. And because I got the talk, the original title would have probably been something like that. I'm just going to reintroduce the Atlassian Web Resource Webpack plugin that was introduced last year at Atlas Camp 2017 by Chris Darroch, and see how we changed it. So in the talk, I'm going to give a bit of context in how I came about developing on that Webpack plugin, how basically a bit of thinking made me redraw the map on how to think about P2 front-end development in the first case. I'm briefly going to introduce the tool that we are going to talk about today, and also the example that we demo through that is available, so you can use that later on if you want to have a look again. Yeah, we're going to walk the walk. We're going to go through a demo of a P2 plugin development, and if we have time, I'm not too hopeful about that. There's a small bonus round, how we can use the ideas and the paradigms from developing that plugin into other parts of server development or plugin development in server. Okay, a quick show of hands here. How many people more or less regularly hire front-end developers? And how many of those sometimes struggle to onboard them because working on the front end in P2 is not so much fun? A lot of people like P2 environments. So in Atlassian, we call the thing drinking from the fire hose. And it involves more. Like drinking from the fire hose generally means you're overwhelmed with information of some sort. When you start at Atlassian, you have to get used to the culture. There's a massive culture that you have to get used to. There are rituals that you have to get used to. But one of the biggest things that struck me, coming from my previous job where we had all the nice and shiny of front-end development, was that I now had to get used to a rather awkward dev loop. You had to write your dependencies in XML. You didn't really have all the nice and shiny out there. You wrote AMD modules. They weren't even related to the file names. There were a lot of transitive dependencies. There were a lot of globals that just were there, and there's a lot of tribal knowledge. And that's not all bad. If you look at the age of some of our products, they're well over a decade old, and look at JavaScript at that time. JavaScript just didn't really provide anything. There was no idea of a dependency management whatsoever. And so everybody had to come up with something. Atlassian came up with WRM, the Web Resource Manager. It allowed you to specify dependencies, which is nice. It even allowed you nice things like loading certain parts of your application asynchronously if you created a web resource and you remembered the name. So that's pretty good. And then there's this general thing, like if you look, for example, at Java code that you wrote 10 years ago, if it was solid Java code 10 years ago, it's solid Java code now, kind of like a good wine. It will age pretty well. JavaScript just doesn't. JavaScript is wine in a Tetra Pak, and you want to get rid of it rather quick. So I doubt there's a lot of JavaScript out there that was written 10 years ago that people would write the same way today. And that was kind of me starting there, and I was like, oh, is this really how life is going to be? And then pretty much a year ago, here at Atlas Camp 2017, Chris Darroch held a talk, and it was server add-ons for front-end developers. And the idea was, can we use some of the nicest, we have a very vibrant JavaScript ecosystem, and it comes up with amazing tooling. Can we use some of that to relieve us from some of the pain that P2 is causing us now? And the idea was that if we already define modules, if we use AMD, we can use Webpack to bundle them for us, and then use the entry point, the generated code from the entry points to generate also an XML file for us. So it takes some of the pain away from us. We don't have to write XML dependencies anymore. It did have some shortcomings. It was a very initial idea, but it did some of the job right. And I was still, part of my mind was still not convinced to give up. And I knew this other world. And I was like, maybe I don't want to just take the edge off of P2. What about if we rethink the whole thing? What about if I could, as a developer, focus on creating value, of solving problems for my customer, instead of trying to replicate what is out there already and try to replicate it into a P2 environment? So basically, and that's where we come to redrawing the map, it's how can we maybe write a system or a tool that allows us to use whatever we want to use, whatever's out there, whatever best does or helps me with doing my job, and then just force it onto P2. So what do I mean? This is the list. So this comes back to the title. A fast dev loop, high quality performant. This is by all means not a complete list. And some of the things here are not specifically front-end, but also are based on the Atlassian ecosystem that you live in. But in the ideal world, so we're starting at fast dev loop at the top with simple onboarding. Ideally, my developer experience should be easy to onboard. If I hire someone new, if I bring a new member into my team, I want them to be productive as soon as possible. I want them to be as productive as soon as possible because it's motivational for them. If you can raise a PR on your first day and it gets merged soon, you're like, wow, I'm productive myself, that's cool. I don't want them to spend the first 2 months or whatever to learn all the tribal knowledge they have, to learn the syntaxes that are specific for some of the parts of P2 or learn some of the transitive dependencies. So is that if we just look at, if we would now create a plugin with Atlas create plugin and just use whatever's provided to us, that's not an easy onboarding. Same comes to known environment. I want to use whatever tool best solves problems for me. The status quo, the current status quo of P2 is not very supportive of that. Nbm dependencies. There's simply no real easy way for me to update them and to consume them at all. Whoa, that's too much. It's very red. I mean, you know where this is going. I want to use the latest features. Pretty much a bit more than 2 years ago, I was at the conference here in Barcelona, and there was one of the members of TC39, and he said, like, it was like one of the questions I think after the talk was, will we ever stop transpiling code, or when do you think we are stopping to transpile code? And he basically said, and by all means he's not the single source of truth for that, but he said, JavaScript is never going to be a standard language anymore. You're always going to be transpiling. You don't want to wait. The language itself wants to evolve so much, you don't want to wait for every browser to support it eventually. And so I want to use the latest features. And that's not just things I can transpile, that's also, if there's promises out there, I want to use promises. If there's fetch instead of XHR, I want to be able to use that. Currently, out of the box, not so easy. Immediate feedback. Especially in the newer frameworks that are out there, Vue or React, you have things like hot module replacement. So you can basically develop something and immediately you see feedback. At least when it surfaces to the UI, and even like if you have underlying business technology that changes how the UI will look like, you surface this immediately. I don't want to wait for Maven to build for 5 minutes and then update something and then refresh my browser just to figure out I had a typo. And this is probably truer for you than for me. Lucky for me, yeah. I want to reuse my code in cloud and server, right? I don't want to rewrite a lot of things twice just because the environments are so different. When it comes to high quality, of course, a fool with a tool remains a fool. So if you write bad code, you write bad code, but you can have tools that at least support you. And I think static analysis is one of them. You get them if you have something like TypeScript or Flow, even if you use ES modules. ES modules, by spec definition, have to be statically analyzable. And that means you get certain benefits. If you use IDEs like IntelliJ, they will tell you you can't import this because it doesn't exist. They also allow you to then easily rename or refactor your code because basically they can analyze which parts get exported from what part of the module, and you can easily rename things throughout your application. Same thing comes for ecosystem benefits. again, the JavaScript ecosystem is probably one of the most vibrant out there. And they come up with crazy stuff all of the time, but a lot of them require to have some sort of visibility of your dependency tree, which means they have to have access to your dependency tree in order to do some of the analytics and some of the magics, whatever, that then to provide you with dev tooling, whether it's React tools or all of these tools that are out there. One of the most important things, I guess, is I want my code to be the single source of truth. I don't want to specify all my dependencies in JavaScript and then specify them again in XML. I also don't want, and this is probably my opinion, and there will be people disagreeing with it, but ideally I want my app code to have explicit dependencies on every part of my application. That can be my styles, that can be my assets that I'm loading. Ideally, if I have a component-based architecture, or I have components in that sense, ideally I can be sure that if I don't use that component anymore, I can delete it with all its styles, all its assets, it's just gone. Currently, CSS for most applications is an add-only API or append-only API, because we never know who might still be using those CSS classes somewhere out there. Someone might be concatenating some string over there, and then suddenly I'm killing his application if I delete the CSS. And yeah, I dislike them so much, I added them as the extra point. I do not want to write my dependency graph again in XML. And then we come to Performant. With this ecosystem benefits, I mean, a lot of that is kind of duplicate. I want to have some things like that code removal. Like, that comes as easy as if I don't import a certain module anymore, even if I don't delete it, as long as it's not part of my dependency tree, I don't want to load it, just because it's specified somewhere in a web resource. If I import a part of a library, I want to make use of tree shaking or scope hoisting in order to get rid of all of this code. Well, I don't want to do it, but there's tools that can do it, and I want to use them. Same goes for code deduplication. If certain parts of my application use the same parts of their code, they should only be loaded once, and they should share them. This is kind of possible with WRM. If you get really into writing a lot of web resources, you can do that. So that's a yellow-red. Same goes for on-demand loading. I mentioned it. WRM provides you with a way to load web resources asynchronously, so you can do on-demand loading. There's just a standard way in JavaScript that's much easier and much better to use. So again, it's more of a red-yellow. And then there's cross-plugin code share. So ideally, we do not want to bundle every piece of code ourselves. So we all basically, me as JSD, live on top of the Jira platform, or you can be on Confluence or Bitbucket, any of these products. They have a certain range of libraries, and ideally, if that's possible, and they use the version that I need, I would like to be able to just reuse it again. Again, this is possible with WRM if you know the right strings. If you know the right dependencies that you have to specify in your web resource, and if you know what the web resource is called in the first place. That all being said, and that's a very dark picture, I'm sorry for that. We're going to make it better. I'm going to reintroduce the tool that we are going to talk about today. So there's go.atlassian.com/WRM plugin. You may take a picture of it. Don't have to download them now or anything. And we're going to use the WRM plugin minus example. That's the thing that we're going to run through now as a demo, and then see how that can help us in these points that we just mentioned. So I think this. Yeah. Quick, brief run through of what we're going to do in the demo. I just created an empty P2 plugin. I cleaned out all the Java stuff. I added a Webpack config there. We're not going to go too much into detail of how Webpack works or what the config does for the parts that are non-interesting for this talk. We're going to have a quick hello world. Then we're going to we're going to grow a web panel and add specific use cases that are all dumped down. They're very simple use cases, but they can be used to then have a more complex application in the future. And then as a recap, we see how many of the points that we just saw in this awkward table that might be better now if you start using that or make use of this plugin. And that, having said that, I'm going to switch over to our demo. So what you see here is that's just my terminal. We have a repository here, and this is the one that I mentioned, the WRM example repository. I'm going to jump through certain commits and then rerun the app again, and then see how these changes surface. So don't get too confused about what happened in the terminal. I'm just skipping through commits, basically. And over here, we see we have a locally running Jira instance, and currently we see nothing. So let's get started. We have I have Visual Studio Code. Is that visible, or should I make it a bit bigger, probably? Yep. Is that better? All right. So this is our empty P2 plugin, if you will. We added a front-end folder. Don't. Let's not bike chat about whether that should be in front-end or in resources. We have a completely empty Atlassian plugin XML. And then in our front end, we have a Webpack config here. In our index file, we just alert all Atlas Camp 2018. I can't speak that in Spanish. I don't know what 2018 in Spanish is. And then here we have a Webpack, our Webpack config. It's a very standard Webpack config. We specify our entry point as Atlas Camp 2018. And then the interesting part really is down here. This is the WRM plugin. What we have to specify is a plugin key, the plugin key of our P2 plugin, and an XML descriptor path. You saw these longer things here. So we're directly going to build into the target directory. And this XML descriptor is basically the path where our plugin hopefully generates the XML for us. You have to activate in the POM XML that you support the fragmented Atlassian plugin XML. This is this part here. You say, look for fragments over there. But that's pretty much all the magic that's in there. And then finally here we have a so-called context map. That's one of the options of the plugin. And we say for the entry point Atlas Camp 2018, make sure it's loaded in the context ATL general. Don't do that. Don't use ATL general. Why did I do that? No, but okay. So I'm going to build this now. So this is just triggering a Maven process that is going to build the plugin. Part of the Maven process is going to trigger a Maven execute plugin or Maven frontend plugin that is going to run Yarn. Yarn is going to execute the Webpack. And then it's going to push all of that into our running Jira instance. And if we refresh this, then hopefully we see an alert. Yeah, it worked. We can alert everyone. And so we pretty much achieved a lot here already. So we didn't write any XML code. So yay us. So what happens is basically over here, part of what the plugin does for you is it generated this plugin descriptor, WRM bundles. Ignore parts of what you see here. It's quite verbose. Should be cleaner. And then we generated this Atlas Camp code. You can see it here. That's the whole runtime Webpack stuff. And then eventually here's our little module. That's not really a module. And here it references this, and it makes sure that it gets loaded onto ATL general. So the very basic thing is working. That's good. Let's go to the next step. Let's create an actual a web panel. So what we do here is we add a little web panel VM here. Yay, velocity. It's an empty div. It has a class name. That's pretty much it. Then in our Atlassian plugin XML, we specify that we want to have a web panel. It should show up on the right context of an issue in Jira. And then in our index file, we now say, once you're ready, like once the DOM is loaded, so we know that actually this class exists, take the class and then write all our Atlas Camp into it. All right, let's try that. So this will eventually update our Jira instance. And if we refresh, we get a web panel, and it says Hola Atlassian. So that's already almost practical usage. So yeah, that's good. Let's continue. So what else can we do? This is still awkward, right? We talked about it, like we now have XML generated for us, but this is really slow. I'm still building my plugin every single time. So let's use watch mode, right? How do we do this? I'm starting it already on the back side. This is a bit tricky. And the tricky bit here is that the way P2 works is, and why you have to specify XML files, is that it wants you to generate, it wants you to tell you statically, this is the resources I'm going to load, which doesn't work with hot reload because by definition, they're not static apparently, they're very dynamic. I'm gonna change them all the time. But that doesn't really work with my XML file. And I'm actually gonna kill this process quickly again to show you how we get around that. And the idea is, it took a while to get there, and then it sounds really logical, kind of. It's super trivial. So what we do is, in our Webpack config, we specify, we extracted this part out now. We added more configs to our config. And what we have is now we have a Webpack watch config and a Webpack prepare config. And we have a WRM plugin function that gets us a WRM plugin, and we have watch or watch prepare specified. And what that basically does, it's not that magic. So in a watch prepare config, we call it with true because it's the prepare step. And we have to specify our output in a way that it's an absolute URL. And in the watch config, we just start a dev server. And down here, we use Webpack Merge to then merge them together based on the environment we are running it in. And basically what this does is, first it starts Maven with a profile that tells it to start it with the watch prepare config environment. And what it generates for us is basically it takes all of our entry points and all the important chunks that we need, and it just redirects them to the dev server. And once that happens, basically our frontend is connecting directly with the dev server. And if we refresh now here, and we look into the code, so I'm using this, is that visible here? No, I guess not. We can also use VS Code if that's easier. But basically, we have all of Atlas Camp here, and then if I change something here, I hope this works, and I save it, the Webpack Dev Server tells our UI to refresh immediately, so it reloads it, and we have our update. So that's faster. We don't have to rebuild our plugin anymore. But that's not good enough, is it? We want hot module replacement, so how can we get there? Ideally, you have one of those beautiful new frameworks, and you just install some weird loader, and then it happens out of the box. What we have to do, because we have some legacy code maybe, we have to split up our app now. Hot module replacement only works on the child nodes of your root node, basically. So the root node, the topmost file in your dependency tree can't update itself. It will always just refresh the browser. So what we do now is we have a web panel.js where our code lives. We export it as a function. We import it here as the function and call it. And then we say module.hot, that's Webpack-specific syntax. And really, 99% of the cases, you will not need that because you can just take something out of the box that is provided for your framework. But if you want to do that, we basically just say, we depend on webpanel. If webpanel changes, we accept the change for webpanel, and we are requiring the new webpanel now. This is looking a bit awkward, to be honest. And we can't use ESM here, so we have to use it we have to require it via CommonJS. That's how Webpack wants us to do it. And because CommonJS doesn't know what a default export is, we have to call the .default on it. And now if we try this again, and I quickly just refresh to be sure that it's working, then this should not reload the browser. And it's just there. So we now have hot module replacement inside our, theoretically even our legacy apps in Jira. And you can do everything here. You can go crazy. I like this so much. So, yay. This is working. So this reduces our dev loop down from waiting for Maven to build it, eventually for a bigger plugin for several minutes, to literally sub-seconds of update. So that works. There's still one awkward thing that you might have seen, and that is that we are still requiring jQuery globally. And ideally, we wouldn't want to do that, right? We want to import our own dependencies. We want to at least specify, like, we don't want to rely on jQuery to just be there because we think it's there or we know it's going to be there. We want to specify our dependencies directly. So what we do here is we import jQuery. I sneakily already installed it in my package.json. And so what we can do now is, and to show you that it's actually a different jQuery version, because this is working apparently, it says it's still working, we can ask for the version that is actually shown. And Jira still has a different version, I hope. So if we update this, it will tell us that we're currently running with jQuery version 3.3.1. If we go back to our global jQuery, is that, by the way, visible here? I can make this bigger as well, I think. This looks weird now. But so if we save that again, we still have a global jQuery theoretically on the window with 1.72, but we can now use our own jQuery, just import it, and it's part of our dependency. So that's good. So we now can use NPM modules. If there's a problem out there that is already solved by external dependency, feel free to just use it. And our app grows. We now have asynchronous code. Yay. So we want to use on-demand loading, because as you heard today, like, DC becomes more important, and performance becomes one of those issues. And so ideally, I don't want to load all my code all the time. If I want to write like an SPA somewhere, I only want to load the navigation item that is currently shown, not all of it at once. So I need something to load things on demand after the initial page load. So we now have an async code here. It's a trivial method. It's called later because it's async. It gets an element and it renders this was async into the element. Our index is still the same. Now our web panel, we now changed it a little. We now get the web panel and we render a button into it, and then we listen for the click on the button. And then once the button is clicked, we say import our async code here, and then call the later function on it. So in theory, this should still work. So if we click this here, it loaded async. You can now, of course, you're free to say that this is because we are running on a Webpack Dev Server, and that's of course why it's loading, just proving that it actually loads async at all. So if I click this, it loads our 0 chunk. But that's because we're living in Webpack, in a Webpack Dev Server. We're currently communicating with a Webpack Dev Server. But this is, and I'm going to kill our watch mode now and actually run it as if it was production code. This uses the WRM require under the hood. It generates a web resource for you for the async chunks, and then makes sure that if you want to require that it actually requires that through WRM and then registers it back with Webpack. So if we try this again, and I'm hoping it's not too awkward yet to wait. If I click here, we now see it actually requested the batch for us. It loaded the batch. It's the 0 batch because that's the name of the chunk. And it loaded that code asynchronously for us and executed it. So this is also working. So we can now load code on demand very easily. It's the standard JavaScript syntax. It's just dynamic imports. That's pretty much it. All right, what else can we do? Maybe we make our code a little bit more productive or usable. I go back to Jan Watch. And we want to use images. And this is basically, the next 2 steps are going to be, they're a bit flavored from my perspective. I like to have all of my dependencies in my code. So I have my single source of truth. I have my dependency tree of all my dependencies, all of my assets in one place. So we're going to load an image. And how we're going to load this image is, in our async code now, we are importing an image. We have our Webpack configured in a way that it knows how to handle images. It returns, we're using the file loader for it, and then we're just going to render an image with the image source. So if I click load image, it will load a gigantic image of a red moon. And ideally, we would crop the image smaller because that's much too big. But I'm lazy, so we're just going to use styles. And this is very much the same way. So we are importing styles. We're using styled modules now. And we're going to set the class moon to our image. It says use the width of 70%. And if we refresh this, then ideally our image is now only 70% of the width. So this is nothing special. I mean, I'm just walking through how Webpack works here. I'm sorry for that. But you can use this inside your P2 plugin world now. There's nothing going to stop you from using all of this. Let's continue. Our app grows. And for some reason, we don't only want to load the moon, we also want to load the sun now. And we also started using Lodash because Lodash is cool. So we take our element, we put it in an array, and then get it out again. There's only one problem with that. I mean, it's working beautifully, but we now have, I'm actually going to go over here and add name chunks. The problem that we get now is our app grows. So our moon chunk and our sun chunk are now 550 kilobytes for doing nothing because they import Lodash. Wouldn't it be nice if they just loaded it once? So just to show this is still working, sorry. So we can now load the moon and the sun. Yoo-hoo. Beautiful images. So ideally, we want to make use of code deduplication. Because what currently happens is, because they are both async chunks, Webpack is smart enough to know that jQuery, which is also used in them, is already used in our web panel. So it's not going to load it again because it knows the module is going to be available before an async chunk is going to be loaded. However, if you load two different async chunks, it doesn't know which one comes first, so it can't make the assumption that you can already assume someone else brought Lodash along. So it will bundle it twice. And how you get around that is by using split chunks, or in this case, even async split chunks. And basically what you specify here is, I actually have to go to that code. So we just add some split chunk config here. You shouldn't probably use this one. This is the bare minimum. It will just chunk everything. You have to play around it a bit. I find the default settings of Webpack a bit too restrictive, where it only starts chunking modules when they reach a size of at least 30 kilobytes. But you have to check what works best for you here. If we use this again, it will have built the moon and the sun chunk for us. But actually, if I restart this, because I changed the Webpack config, it will now start to try to split up as much of our code as possible. So if we look at what it built this time, we now have, this is not the one, here it is. Wait a second. We should see chunking. Let me try this again, sorry. Okay, for some reason it doesn't like me right now. Sorry, I remember. I almost remember. So we have to use our yarn update here. And the problem here is, and that's a bit awkward, and it's a technical detail. We created a dev config that you can't use split chunks when you're running in watch mode, because of the nature that we have to generate XML files, and that chunks are can change at runtime. We basically would have to know what XML file we have to generate before we pass it on to Jira. And basically, once you start adding chunks and the chunks change, they wouldn't reflect anymore the same in watch mode than it would for what you currently are actually building with Webpack. So it's not really a problem in the sense that in the development loop, you don't need chunking as much as you would then if you want to test it properly once with the dev environment or once you get it out for production. So if we look at what it generated for us here, we now see that it actually started chunking. We have our moon chunk here. It's only 2.65 kilobytes now. It created a moon sun chunk. I'm not entirely sure what's in there. It's probably some stuff related to the lesser CSS loader. And then here it created the vendor's moon sun chunk. And that's 545 kilobytes. That's our Lodash that's now got extracted. And it's smart enough to now basically create XML for us that generates the dependencies that still make it work for WRM to know what's happening. So if we If we refresh the page once more, and you'll all be sick of suns and moons by the end of this talk. And we load the moon, it now loaded 3 batches for us. It loaded the vendor batch, which contains Lodash. It will load this moon sun batch. I don't know what's in there. And then it will load the moon. And the beauty of it is, if we now load the sun, it will only load the sun batch, because it knows that the moon and sun batches that both of them share already loaded. So you can now reduce the size of your code if you have multiple on-demand on-demand code paths that can execute and share code between them. So all of this is taken care of. The plugin will take care of that for you. Next step, and that's, I think we're getting to the end, is the last, and one of the most important ones probably, and that's provided dependencies. And we call them provided dependencies, and that's coming back to the point where we say, if there's jQuery out there, why do I have to bring my own? It will lead to, like, especially when we talk about scale and performance, if everyone brings all of their libraries all at the same time, we add a lot of libraries on top of the weight of the page. But we do not want to, at the other hand, give up on our dependency that we define. So we came up with something called provided dependencies. And this is a bit awkward. Ideally, we would have some NPM module that you could consume, and we would give you a build target you can build against, a number of provided dependencies in a version range that you can build against. It supports it for now, and we have to do a better job as the platform to provide you with what you could use. But basically what it says is, it says, when you detect that jQuery is being imported, actually don't import jQuery, but just add a dependency to the Jira Web Resource jQuery, and then get it from the global namespace. Just get it globally. We used Lodash. I'm just giving underscore 1.44 here because I know it exists. You probably shouldn't do that necessarily if you don't know if it's working. But basically, this means I still have my code here. Like, my code still requires Lodash and jQuery. I don't want to give up the fact that I have my dependencies explicitly specified in my code, but I don't actually want to bring everything on my own if I know the platform can provide me with these dependencies. So if we run our code once more, we will now see that Webpack will have reduced the size dramatically. We see the image here. We didn't reduce the image size, but basically our vendor is now only down to 16 kilobytes. Our moon and sun chunks and everything else is in sub 10 kilobytes. Instead of loading over a megabyte before, we are now loading at maximum maybe 20 to 30 kilobytes. So if we refresh this, it will basically rely on us to dynamically link. It's kind of a DLL thing, to dynamically link us jQuery and Lodash at runtime, or underscore 1.44. And if we click this, it's still all working, and it's still all doing what it's supposed to do as before. All right, so coming back and recapping. So what did we see? Is it simpler to onboard now? Kinda. You're still in P2. You still will have to learn some of the specifics of the P2 environment, but I would argue that if you bring someone into that, once you've set it up, which is non-trivial maybe at the beginning, you can set someone there, and there's ES modules. He doesn't have to know that there are provided dependencies or not. It might get to the point when you have to debug that they exist, but he can generally just start working. There's nothing specific here that you don't have to know that you can't use dynamic imports or that you can't use chunking. You could just use whatever you want. Same for the known environment. It's a tricky thing. It's not the green field that would be out there if you didn't have anything. You're still having some of the constraints of P2, but they're mostly relieved, I would argue. When it comes to NBM dependencies, NPM dependencies, you can just use them. We saw that. You could import jQuery if you want to. You can use your own version. You don't have to use what the platform provides you with. Use the latest features. That's a tricky one. As far as you can transpile, I mean, all of the Babel loaders and all of these kind of transforms are available for you because it's just Webpack. There's nothing special about that. When it comes to actually using some of the polyfills that you need, it's tricky with us, I know. So everyone that brings another core.js into the game is just going to explode. There's some trickiness involved around there, and we could probably do better here. But the plugin can't really solve that for you. When it comes to immediate feedback, we have hot reload or hot module replacement. There's nothing stopping you from using that either. When it comes to cloud server reuse, again, it's a bit of a tricky beast. I think there could be, of course, a better world. You can write your logic once and most of your UI once, I guess, and can consume them, but you will have to have certain different building mechanisms having to actually glue everything together because you're building against different targets. It's not that we changed the way you have to develop. You're living in a different environment than you would in cloud. When it comes to static analysis, you can use TypeScript Flow. You can use ES modules. You can benefit from the ES module static analysis. IntelliJ does an incredibly good job at highlighting which parts of your code are unused. If you want to rename or refactor things, it will do all of this for you very good throughout your code base if you have your code specified in ES modules. Ecosystem benefits, you can use whatever's out there. Again, like the environment is not stopping you anymore from using any kind of dev tools that are out there, any kind of coverage reports whatsoever. You have the same front end as anyone else in that sense. Single source of truth also, you can specify everything and you can actually do more. Like if you look at the repository, sometimes you will or may be required to have WM dependencies specified as side effects that you can't really import. You can't use the provided dependencies for that because there's simply nothing you can globally consume. There's a special syntax we have that you can use that we strip out again but add the dependency to your web resources where you need them without exploding your code. And yeah, you don't have to write XML dependencies at all. Like there's no XML involved anymore, except if you want to specify web panels for now. Sorry. That code removal, as far as this goes, it's just Webpack, right? At the moment you have Webpack running, you get tree shaking and scope hoisting and everything out of the box. As far as this is concerned, it's just going to work. You can still kill it through, it's a very brittle thing, the whole tree shaking and scope hoisting thing, but as far as it goes, you can just use it. There's nothing going to stop you anymore. Code deduplication, we saw that as well. You can use split chunks. You can use async split chunks. You're still living in a WRM environment.
No, we can hear, you're loud enough.
So WRM can sometimes still cause issues there when it just batches too much together on one page, which means that if you move to the next page, even though you know you have loaded it all already, it will still load different super batch or different concatenation of batches, and therefore you load everything again. But the moment you go into on-demand, it will separate all of your code from everyone else's, and it's perfectly fine to code split and code deduplicate there. On-demand loading, we saw we can just use dynamic imports. It's just going to work. You don't have to write any WRM requires. You don't have to remember any string names of any web resources. You can just do that. And as far as cross-plugin code share goes, it's kind of possible. There's this awkward thing that you have to know the strings of certain web resources, and you have to know that where to find jQuery. I want to promise that we'll do a better job on that one, and then provide you with a target that you can just simply build against, based on also versions that you have specified in your package JSON, for example. So you get the library only bundled if it really matches your dependency or your requirements. And that all being said, once again, these are the two tools we used. The one is the Atlassian Web Resource Webpack plugin. The other one is the example file if you want to go through. Give it a try at least, please. Thank you.
Thank you. That was fantastic. You ever go to a talk and you're like, wow, that guy really knows what the hell he's talking about? It's kind of one of those talks, so it was a pleasure to sit and listen. We're over time, but I got a feeling that nobody really cares. Anyone have any questions for Tim? Yeah? All right.
Hey Tim, thanks man. That's a fantastic talk, one of the best I've seen at Atlas Camp. I gave a similar one about 3 years ago using Webpack in P2 modules, and we've been doing that at Easy Agile for the last 2.5 years. One problem we have is source maps. So we use Bugsnag, and we can upload the source map to Bugsnag, but unfortunately the web resource manager changes the line numbers and that doesn't match up. Do you guys have a plan for that kind of approach?
It's a good question. The quick answer is no. I think you should be able, the moment you actually So it's tricky. So as long as you're developing, because as soon as you hook into the Webpack Dev Server, you will get all the source maps you have. But if it comes to bug snatching later and then seeing actually where did it cause it, it's trickier than that, I assume. Yeah, I wish I could give you a better answer, but we should put it probably on the roadmap somewhere. Yeah, thank you.
Is there any reason that we can't use this approach in Confluence?
You can use it in every server product.
Then any recommendation for macro web resources?
I didn't look into that. I'm sorry, but yeah, maybe if it helps to give some context. So JSD is completely built on that now. Jira is starting to use it more on their satellite plugins because it's just this massive code base. Confluence, I know, starts using it in some of the newer plugins they're developing. Bitbucket Server is currently looking into adopting it. So it's internally being used, and it's going to be actively developed. So it's not something that is just a proof of concept anymore. It's beyond that point.
So just like to thank you again for that great talk. And also the guy from Easy Agile whose talk 3 years ago, I think it had document write line in it. And that totally transformed the way we do front-end development. So thanks for that. You talked briefly about problems when you include Core.js and Babel polyfills. And we had major problems when other plugins also did the same, but a different version. I wondered if you had any plans to polyfill the environment to like a reasonable level so that vendors don't get into this problem.
I wish I could say that it's a done thing. I don't know how much I can say. We are very much aware of that issue. And ideally, we agree, all products agree that we should probably provide a certain environment that you can just trust as a baseline. It's maybe a bit too much detail, but some of the products disagree on how much they want to give. So some might want to do more than others, but at least that we can have a standardized baseline that you know this is going to be a provided thing, and I don't have to bother about Core.js. I mean, this is for us easier than for you because we have one version. Going forward, if you can rely on that coming in certain versions of our product forward, then you know, okay, from here onwards I can rely on that polyfills. But that just means still, like, the moment you go down from that version, you will have those problems again. I'm not sure how, especially when it comes to different versions. I guess it's tricky, especially when it comes to polyfilling certain globals and stuff like that.
Actually, can you just come up after so we can let everyone else go? Thanks again, Tim. Fantastic talk. Yes.